Schemas, users, privileges, and roles. Schemas and users. What is a schema? A schema is a schematic. A user is a user using the schematic, either directly or indirectly. In Oracle, a schema and a user are actually the same thing. However, the schema is used as a central repository or area to store table structures and data. Users can be multiple users looking at a single schema, as in DBAs, system users, developers, and application end users, amongst others. As you can see from the diagram on the right, the Oracle database is surrounded or contains a number of different schemas, where multiple users will look at many schemas or individual schemas. System users, DBAs, and developers do work on the schemas in the Oracle database, whereas Internet users or application end users will be passed through something such as a web server using either a single username on the Internet or multiple client-server users, and will either look directly into the schema usernames or other usernames which are connected to the schemas. As we've already said, a schema and user is actually the same thing in Oracle physically or logically. A schema generally contains tables, but the schema is also a user. However, there are extra users which will have certain privilege restrictions onto those schema users. Security. Security is handled in Oracle in a number of ways, some very simple, some highly complex. The simplest form of security in Oracle is password authentication. In other words, each username has a password. That password is encrypted and authenticated based on the user. This leads us to privileges. There are a number of layers of privileges. These are system privileges, object privileges, column privileges. There are a number of other levels of privilege allocation, which we will go through in detail. System privileges. What is a system privilege? A system privilege is a privilege allocated to a database object, in other words, a table, an index, or a sequence. A database object, in this respect, is a thing in the database or a logical overlay in the database which allows access to the containers in the database containing the data. In other words, the tables, the indexes, the sequences, etc. The database objects. These particular privileges shown here are, for instance, a privilege that allows a user to create a table, allows a user to create an index, create a sequence. There are many more system privileges. We'll go through those later on. Object privileges. An object privilege really is different to a system privilege in that it allows access to objects between different users. So where a system privilege allows a user to create a database object, an object privilege allows access to an object which is already created in the database. For instance, you could have, as you can see from the diagram, the concert schema here, and now we have another schema called the customer schema. The customer is allowed access to 3 tables in the concert schema: the act table, the show table, and the venue table. There are a number of ways in which access could be allowed from the customer schema into the concert schema using those 3 tables. One way is by using an object privilege and perhaps granting a privilege from the concert schema to the customer schema to allow access, for instance, to the act table, or creation of views either in the concert schema or synonyms, or simply duplication of the tables into the customer schema. 2 of the most common ways is to create synonyms on the tables in the concert schema and allow access from the customer schema or to the customer schema. The second most common way is to simply grant access privileges from concerts to customer. Column privileges. Let's recap a little. System privileges. System privileges allow a user to do things with database objects such as create tables, change tables, etc. Object privileges allow the allocation of access to tables between users. In other words, allow an application user to access for instance, one of the constants tables. Column privileges go a little bit further than object privileges in that they allow the specification of access on tables to specific columns within a table. Views can be used to do more or less the same thing that object privileges and column privileges can be used. Not quite in the same way. A view can be used to pick out certain columns within a table, and then that view can be used by the same user, or access can be granted to a different user. So a view would be more or less a combination of object and column privileges. This is one use for views. Views are used for a lot more things than just privilege allocation. Additionally, it's not recommended to use views to allow access of privileges between users. There are other ways to deal with allocating privileges between users. The best and most simple way is to use object privileges, column privileges, and synonyms, and perhaps even granting access to the objects themselves without the use of synonyms. The virtual private database. The virtual private database was a term introduced in Oracle 8i. The virtual private database was an internal set of rules that could be set. Why I say internal, they can be set internally in the database to allow specific access to different groups and allow access on specific tables and parts of tables, etc. The idea of the virtual private database was that it was automated internally and you don't have to do too much with it. So you wouldn't have to set up object, column, privileges, views all over the database for all sorts of users. Generally, the virtual private database can make object and column privileges a lot more simple to manage. Let's get on to groupings. There are different types of groupings. The first one is a role. Another type of grouping is called a public group. What's a role? A role is an object in the database where you can allocate privileges on objects, etc. to that role. What you can then do is you can then assign that role as a group of privileges to a user. That's the idea. All it's doing is grouping privileges into what could be named groups or named roles, and then you can allocate, for instance, a role called developers to all the developers, a role called application end users to application end users, another role called DBA, of which there is one in the database automatically. There is a DBA role, which would be allocated to DBAs. You can go into a multitude of different levels. The public user group. The public user group is a user group where you can assign a privilege to a table and you can allocate it to everyone, regardless of who they are. Allocating database objects to the public user group is not secure. For obvious reasons, anyone can access that object. You have no control over allocating specific access to specific users. It is advisable to use the public user group cautiously. Some useful DBA tips. Special roles. There are a large number of special roles included generally when Oracle is installed. The obvious one is the DBA role, which is a database administration role. It gives you more or less access to everything. Another interesting role is the select catalog role, which can be granted to a user, allowing that user access to all the Oracle metadata views. It is possible in Oracle to share resources using profiling. Resources such as CPU time and memory, where percentages of those resources are allocated to specific profiles, and then those profiles can be allocated to users. There are a number of metadata views which are useful to interrogate privileges, namely role privileges, system privileges, and tab privileges. User role privs, user sys privs, and user tab privs are some useful metadata views for roles and privileges. Let's take a look in SQL+. Let's connect to the concepts user. And let's do a describe on the first view, which is user role privileges. User role privileges. What this view should give me is all roles granted to the concerts user. So let's select username and granted role from user role privileges for the concerts user. And I can see here that the concerts user has the connect role and the resource role granted to it. Let's go to the next view and we look at user system privileges. User system privileges gives me all system privileges granted to my current user. So I could select username, privilege, and admin option from user sys privs. And here I find that I have system privileges granted to concerts of query, rewrite, and unlimited table space. The next one is user tab privileges. So let's describe user tab privileges. These are all table privileges granted to the concerts user from other users. As you can see, there aren't any because no users have granted any privileges to the concerts user. What I'd like to do now is to show you or give you a quick look at the connect and resource roles. Remember, these roles are deprecated or removed from Oracle at this stage, since Oracle would like Oracle users to construct their own security structures using roles and privileges. However, the connect and resource roles tell you more or less what you need in order for a user to connect to the database. So let's type in select. First of all, let's go and look at what we need to do. I need to be connected in order to look at this view. The role sys privs view, I need to look at this particular view logged in as a DBA. So I'm going to log in as my sys user. SysDBA. I'm going to type, first of all, let's describe the view. Role sys. This gives you privileges, system privileges assigned to roles. So role, privilege, admin option. The role is the name of the role, the privilege is the system privilege assigned to the role, and the admin option allows that role to allocate it to someone else, assign it to someone else. The user who receives the grant to the role can also grant administration of that privilege to another user. So now what we're going to do is we're going to do select. We can look at everything, so we use star from role sys privs. And we only want to look at connect and resource, so we're going to use role is in connect and resource. This in clause is another part of SQL which we will get to at a later stage. What do we have? Here's the connect role. Here's the resource role. As I said, connect is really for end users. Well, perhaps that's not strictly true, because an end user would only really require an alter session system privilege and a create session system privilege. That's what allows, that's the minimum. Alter session, create session is the minimum that allows connection to the database. The connect role also allows creation of certain database objects such as tables, synonyms, views, etc. These are not essentially required for end users. You don't necessarily want end users creating tables in your database. In fact, you probably really don't. This connect role is more of a power user type role, really, for, if you like, a combination between an end user and a developer. The resource role is for developers. The resource role really extends the connect role. So your developers would have lots of create, alter, drop, etc. privileges on objects, probably only within their own schemas so that they can't drop database administration objects from production databases. End users would really have alter session and create session. A DBA set of privileges would look slightly different. We could go and look at a role called DBA, and we'll actually say in DBA. We could go and look at the DBA role, and you'll find that there are a lot more privileges there. As you can see, we have 124 rows. Fitting it all together: the database, schemas and users, privileges, and roles. Let's just go through this diagram. Schemas and users, the same thing, one and the same, are included in the Oracle database. The schemas contain the tables, your data. Users also are the same thing as a schema, but you can have other users who can have different functions on that set of tables or schema. Privileges, either system or object or both, are assigned to schemas and users. Privileges can also be assigned to roles. As you can see, there are different types of roles here, and roles can be assigned to users and or schemas. It's important to note as well that roles can also be assigned to roles, so you can create roles such as connect and resource, and then connect and resource can be assigned to a new developer role which you could create. That role is called developer. So the developer role could have two roles assigned to it, namely connect and resource. This is how it all fits together. We have privileges assigned to roles and users, roles assigned to users, and users contained within the database. Types of users, types of database users. All I want to do is just present the different types of possible Oracle database users, just so you can get an idea of the scope of the usage of an Oracle database. Database administrators. Database administrators administrate the database. They maintain, tune, and make sure the database is up and running properly. Traditionally, database administrators sit in the background. Nowadays, database administrators tend to be involved in all aspects of anything to do with the Oracle database, from data modeling to tuning SQL code to the operating system layer underneath, such as Unix administrators, networking, anything and everything. Security administrators. A security administrator is really a person who is a subset database administrator, possibly a junior database administrator, whose responsibility it is to assign access privileges, or quite simply access to different users, be they end users, DBAs, network administrators, developers, etc. Generally, people like security administrators are only really needed in very large companies with large databases. Network administrators. A network administrator is a person who administers the network. If something goes wrong with the network, this person repairs the network. Quite often, Oracle database administrators are originally network administrators. They have network skills. Systems administrators, many Oracle DBAs are sysadmins. They know a lot about Unix, Solaris, HPUX, Veritas, that sort of thing. Database administrators, in my experience, stem from either a Unix systems administration role or a development role. And obviously these different types of database administrators have a different perspective. Applications developers. Applications developer users are basically programmers, coders, web developers, Java developers, etc. They will have some access to the database with certain restrictions. Applications developers can quite often be data modelers as well. In other words, the people who build the tables and the entity structures, the relational database structures, are built by data modelers. However, database administrators can often be data modelers as well. Testing people. People who simply sit there and test the software. They know something about the database, they know something about the applications. Testing can either be written as large suites of code, or simply as people actually sitting on the database or sitting on the application and testing everything right from the application layer down through to the database layer. Power users are really end users with special abilities. Well, we shouldn't really say special abilities, but special capabilities in the database. In other words, a power user could not only connect to the database, but that power user could also create objects and, for instance, run ad hoc SQL statements. Power users have to know something about, for instance, SQL code, such that they don't either crash the database or lock it up by selecting all the data in the database at once. End users are really your customer type users. They're not skilled in the use of the applications or the database. They're not expected to be skilled in that respect. Their objective, or the objective of all these other people, is to make it as easy as possible for this end user to use your application. So really your database is totally transparent to the end user. The end user goes into the application on the web or in a client-server situation and just types on the keyboard and clicks the mouse, and that's all he should be doing. The create user syntax. The create user command is used to create database, Oracle database users. In its simplest form, you would create a user identified by a password. The externally option allows identification by an operating system username, and the globally as external option name allows authentication across a network from a remote machine. The grayed out areas are once again out of scope. They're database administration, although the profile option allows the assigning of a profile to a particular user. The red options are database administration, but they are important for user creation. For instance, the default tablespace option allows the assigning of a tablespace name to a user, which means that when an object such as a table is created in a user, if you assign a default tablespace, that table will be created in that designated tablespace. The temporary tablespace is used to assign sorting to a specially formatted tablespace, specially formatted and organized for sorting data. Quotas allow certain space allocations on different table spaces. This is a small part of the create user script for the concepts user. Once again, we've got default tablespace data, temporary tablespace temp. This forces any objects created in user into data tablespace. The temp tablespace is used for large sorts where they're forced into the tablespace, and the quotas are assigned to the different tablespaces, allowing, for instance, unlimited creation space for this user on these tablespaces. I want to go a little bit further with this because I need you to understand why we need to set the default tablespace and the temporary tablespace. Go to the next slide to demonstrate a little more clearly. Here we see we have sort space and temp. We have a note here that says the tables and indexes are separated since both are read concurrently, which is generally a good idea. When you create a database, you have a data and an index space. You put your tables in data, and you put your tables in index. The reason why is because the nature of indexes and tables is that they are read concurrently. In other words, they are read at the same time. So if we have them on two separate physical areas, for instance, two separate disks, then it's much quicker to read the two separate disks simultaneously rather than trying to read the same disk at the same time. It's faster to read in parallel. The same applies to what I'm trying to tell you about the default tablespace and data and the temporary tablespace and temp. If these options are not specified, what will happen when the user concepts creates a table, since the default tablespace is not specified as data, the concepts user table will be created in the system tablespace. Same applies to temp, unless when you use the create database statement, you can actually create the database with a default temporary tablespace. In other words, when you create a user, if you do not specify temporary tablespace, it will take the default temporary tablespace from the database specification. As you remember, we talked about hierarchies of files, tablespaces, and tables. Same applies to the database. The database is really one step above the files. Default values are inherited up the hierarchy. Back to the system tablespace. So when we don't assign a default tablespace or a temporary tablespace to the constants user, everything will be created in the system tablespace. Why is this a bad thing? Because this is the metadata. Anything you do in the Oracle database, for instance, reading a table, it goes to the metadata to find the definition for the table, then it applies it to the data and pulls the data out in the right order or the right structure. So if you were to put all your data items and all your temporary sorts into system, every single thing you're doing is hitting that system tablespace. There would be a lot of contention, a lot of concurrency problems where you've got different things reading the same piece of physical space at the same time. This is the reason why we have default tablespace and temporary tablespace specifications in the create user statement. Let's go and take another look at our create user script. What I would like to do is I would like to create a user. I'm going to create an end user type user, so it's not going to be a constants user, it's not going to be a schema user, it's going to be a user, a person who goes in and looks at data and doesn't generally change anything. We're going to create a user called Joe. Now when I say he won't change anything, he won't change any objects. He could add data into the objects, but he won't be dropping tables, creating tables, etc. So first of all, I'm going to change this. I'm going to remove bot command. Let's do the replace first, constants, and Joe. Replace all. Since Joe will be changing data, he may as well keep the quotas, he may as well keep the default and temporary table space. The one thing Joe won't need is all these system privileges in the roles connect and resource. All he's going to need is create session at this point in time. Now what this will allow Joe to do is to simply connect to the database. Now what we're going to do with our script file is we're going to save it as a new name. So we're going to say create user Joe. Make sure it doesn't save it in a text file, and we'll save it. So what do we have? We have a user called Joe. What I'd like to do is actually create this and run it as a script. So what I've done is, if I go back to my Explorer, is I've created a file called user Joe. So I'm going to close this file. What I want to do is I want to run him in SQL Plus in a command line. I could copy and paste it directly into SQL Plus, but then I would have an issue with the way this log file and the path is created. So I'm going to open up a DOS command line shell, and notice how I've gone directly into the directory where my Joe schema / user creation script is stored. Now what I'm going to do is I'm going to type SQL Plus. I'm going to type the name of my DBA user. I'm going to push in create user Joe. What I'm doing is I'm SQL Plus connecting to the sys user at my TNS name, which is my database, and I'm passing in the name of the script, which is create user Joe, with the @ sign. I hit return, and it asks me for my password. It seems we have an error. I appear to have forgotten my sys username password, so let's try another way. Let's try SQL Plus system at DNS name at create user Joe. It will ask me for my password, and it seems I've remembered that one. Now let's go and have a look at the log file. And I find I have create Joe. It says user created, grant succeeded, grant succeeded, grant succeeded. If I go back to my command line window, this is what is produced in the log file. If we mark it, we can see it. That if there were errors, they would pop up in the log file as well. So when you're running a sequence of scripts, you can actually go to the log files and make sure that there were no errors. You could even go so far as writing things like Perl scripts or using Unix shell scripting languages to pass through log files and look for errors when you're running lots and lots of scripts at the same time. That's created a user. Now let's go and create another user. Unlike Joe, who is an end user who has very few privileges, we're now going to create a developer type user who has lots of system privileges. So I'm going to do this in Oracle Enterprise Manager so we can see how to do it this way as well. So let's click on databases and let's log in to my database. This time I'm going to log in as sys because now I've managed to figure out what the password is. Now let's move this across a little so we can see, and we're going to go and create a user in security. So we'll create a new user. Let's resize this a little so we can see. So let's create a user called developer. Profile, there will be no profile. Password authentication, we'll just give him password. Developer, same as his username. The default table space will be data. The temporary table space, as you can see, the system assigned automatically. And we want to go down and look for our temporary table space. His status is obviously unlocked. His password will not expire now. What we want to do is show SQL. If you click the show SQL button, it will show you the SQL that the system is going to run to create this user. So it says create user developer, default profile identified by developer, default table space, temporary table space, account unlock, and it grants connect. What we want to do is we want to change this. We're actually going to grant only create session. So let's go and create this user. The user has been created successfully. And what I want to do, since connect has been deprecated, is I want to go and remove it. So let's clear this screen. Let's connect. And let's do revoke a privilege. We will get on to that. Connect role from developer. And we will grant create session to developer. So now I can connect as developer. Correct. Now let's go and look at the privileges we can assign. Let's first of all take a look at the available roles. Now in Oracle 8, what you would do is you would simply assign connect and generally resource. In Oracle 9, it is preferable to build your own sets of roles or assign individual privileges to developer. So far I've assigned only the create session system privilege, as you can see here, to developer. What we need to do is go a little further and examine what the different privileges are, what they mean, what we can do with them, before we will assign all this stuff to developer. Altering and dropping users. The drop user command is very simple. Simply execute drop user, username, with the option of cascade. Be very careful using the cascade option. When executing drop user username, if the user contains any objects such as tables, you will get an error. Applying the cascade option will delete the user, including any objects contained therein. Let's try to drop a user. Let's connect as sysdba. Now, let's try to drop my concerts user. As you can see, I get an error. It's telling me I must provide the cascade option. I do not want to drop user concepts cascade because that will drop everything in my concept schema, and I want to keep it. The alter user command. Once again, we have some grayed out areas which are out of scope, and we have some red areas which are generally database administration and thus out of scope, but they are important. Once again, the default table space, the temporary table space, and the quotas. I'm currently logged in as my sys user as sysdba. Let's alter the user. And let's change developer's password to password. Now let's go and connect this developer. And developer can change his password back. To developer. Obviously, a user can change its own password. Let's take a very brief look at some security issues. First of all, there are two DBA or database administration users. The first one is system, the second one is sys. The system user contains all the metadata, as we've already discussed. The system user uses the system table space. We've looked at that as well. The sys user is actually the main or primary database administration user. The sys user is used to start up and shut down the database. Starting up and shutting down the database requires administrative privileges. These are either the sysdba or the sysopera privilege. What we can do is we can connect sys at my database as sysdba, or connect sys at ntserver as sysopera. sysdba and sysopera are very powerful privileges which allow starting up and shutting down of the database. It's important to note that sysopera is validated through the operating system and is generally a subset privilege of sysdba. What sysdba and sysopera allow is access to the database whilst it is shut down through a password file. Since the database is not started up, there is no other way to access the database through the password privilege system without using an external file, that is the password file. The password file is a file which is stored in the operating system as an encrypted binary file. Other types of privileges are system privileges and object privileges in general. A system privilege is a privilege granted to a user which allows creation or changing of database objects such as tables and indexes. An object privilege allows access to the information in those tables such as the data rows. Resources and profiles. Resources and profiles are a method of assigning percentages of hardware resources to different sets of users through profiles. As you can see, resource limits assigned to different profiles, where the different profiles are assigned to different groups of users. Resource limits are obvious limits such as processor or CPU time, input-output, and various other items. A percentage of resources would be allocated to a profile as a fixed set. For instance, this profile could get 10% of CPU time, and this profile could get 90% of CPU time. This profile with 10% is allocated to these users, and this profile at 90% is allocated to these users. Therefore, these users would have 10% of the resources, and these users would have 90% of the resources. On user creation, using the create user command, a default profile is assigned to a user. The default profile has unlimited resources. In other words, there is no scheduling of resources between different profiles, as in different user groups. Let's take a look at general system privileges. Once again, system privileges are, in general, privileges allocated to users to allow them to change things in the database, such as creating tables, indexes, altering tables, amongst others. Other privileges are, as you can see in this list below, database and system privileges. Database and system privileges are privileges that allow us to change the database itself, as opposed to the tables. Database privileges are table-based privileges and changing the aspects of the system itself, such as archive logs and redo logs. Most of this is database administration. Once again, this is DBA and sysOPA privileges, which allow starting up and shutdown. Database link, database administration again. A database link is a link to a database on a remote server. Rollback segments. Rollback segments allow the storage of information which allow undoing of operations on the database. Again, database administration. Altering of session values or aspects. Session privileges allow changing of certain profile aspects when you're logged in. When you log in, you create a session. Table spaces, again, database administration. Analyze, to do with analyzing objects and creating statistics. Grant privileges, allowing a user to grant privileges to another user. System privileges are mostly database administration. We don't really need to go further with it. The system privileges we're really interested in for the introduction to SQL are profiles, users, roles, and sessions. Roles. We can do things with roles, as in alter any role, drop any role, grant any role. From the perspective of SQL, a user such as a schema user, such as concerts, could create a role where he would allocate system privileges to allow that role to create objects, such as create views on the tables in the concert schema. The concert schema could then grant that role to another user, such as Joe or developer. Joe and developer are two users we've created so far. Sessions, create and alter session. Every user gets to create session. Every user has to have the create session privilege. Users will get create, alter, and drop on, for instance, tables allocated to them. Here's a quick picture of system privileges. These particular system privileges are privileges which allow users to do things with database objects, as in logical objects such as tables, indexes, sequences. In other words, a user could create the object, alter the object, backup, delete, drop, etc. Do things with these objects. Do things with tables, indexes, sequences, etc. Let's take a look at some system privileges. First of all, let's connect. I'm going to connect a system. Note, I do not need to connect to sys because I'm not starting up or shutting down the database. I'm just going to look at the metadata. So I'll go into security, and I go to users. As you can see, we already have a user called developer. He has a create session system privilege, and the same should apply for Joe. In the top right box, we can see all the system privileges. What we need to do is to be able to scroll across far enough to get the scroll bar. Let's look at all the system privileges. Any that are interesting. Alter any index. There's one. Alter any procedure. Let's go down through the alters. Create. I should find one up here called create table. Create any table. As you can see, there are an enormous number of available system privileges. Let's take a brief look at object privileges. In general, object privileges are privileges which are allocated to objects in the database, such as tables, where we allow a user, or we grant a privilege to a user that allows that user to do something with the information in that object, such as select from a table, alter a table, insert, update, and delete data in or from a table. The same applies to views and sequences and PLSQL. PLSQL, you can execute a procedure. You can grant a privilege that allows another user to execute a procedure. You can grant privileges on sequences that allow selecting from the sequence and altering the sequence, which implies a user can select current val or next val from the sequence. Views and tables are more or less the same. Granting and revoking privileges. We use the grant command to grant a privilege, and we use the revoke command to take a privilege away. Here's the syntax for granting a privilege. The piece in red at the top is for granting a system privilege. So you grant a system privilege, or a role, or a group of system privileges and roles, or all privileges to a user, or role, or public, or a list of. You can also identify by a password with the admin option. The admin option implies that when you grant a privilege to another user with the admin option, that they can subsequently grant it to someone else. Without the admin option, they cannot grant it to someone else. Now the object privilege grant command section is highlighted. The object privilege version of the grant command is fairly similar to the system privilege, apart from the fact that an object privilege is granted onto a list of columns in a table, as in column, comma, column, on, schema, object, schema table. Also, as opposed to being with admin option, it's now with grant option. Admin implies administration for a system privilege. With grant option implies it can be granted to someone else. So if one user is granted select privilege on a table to another user with the grant option, then that second user can then in turn go ahead and grant that same privilege on that same table to yet another user, and so on. The main difference between a system privilege and an object privilege, once again, is that a system privilege is granted so that you can take an action with an object. You can create an object, drop an object, change an object. The object privilege is applied to columns in tables or entire tables. Here's an example of granting privileges. Again, this is the user create script for the concerts user, and down the bottom we had grant connect and resource to concerts, then unlimited table space and query rewrite to the concerts user as well. Note that connect and resource are deprecated, they're just being used for demonstration purposes here. The revoke command is used to revoke privileges from users. Unlike the grant command, which states grant privilege to user, the revoke command obviously does it the opposite way around and says revoke privilege from user. So the revoke command is removing privileges from users. Obviously we have revoke system privilege and we have revoke object privilege. System privileges are revoked from users, and object privileges are also revoked from users as applied to a particular object within a particular schema. Now let's go and do some granting of system privileges. I created the developer user. The developer user needs certain privileges to allow him or her to create and change database objects. So the developer needs things like alter any index, alter any procedure, etc. So what I'm going to do is I'm simply going to go through this list and select various privileges that we think this developer user may need. What I've done is to select a large number of system privileges appropriate for a developer. So now what I'm going to do is I'm going to click the allocation button, and it tells me that it already has create session, but it pushes all the other privileges I've selected into my granted box. Now this is just OEM, but this little thing on the left here is telling you that it has not as yet been executed, apart from the fact that when you click show SQL, which I did, I have all this text in this bottom box. This is
all this text down here is basically all my grant commands. So I'm now going to grant a large number of privileges to the developer user. I'm going to click Apply. Now when I go back here, I find that all these privileges are granted. You note it now says granted, not grant. Now let's go and have a look at the system privileges I granted the developer. So what I'm going to do is I'm actually going to connect the developer at in my database, and I'm going to use a view called user sys privileges. It says username privilege admin option. So I'm going to select, tell you what we'll do. We'll set wrap off. We'll set line size to something large, and we'll set pages to 80. As you know, wrap off will not wrap the end of the line around to the next line. Line size sets the length of the line to 132. Pages 80 means that the headings are repeated every 80 lines. The chances are we won't see the heading more than once. At least we won't see it every 10 lines, and it won't be unreadable. So let's select star from user system privileges. Since we're in developer, we're only going to see developers system privileges. These are all the system privileges we allocated to developer in Oracle Enterprise Manager. Now what I'd like to do is to grant some privileges between two users. We've dealt with developer, who is a developer who has lots of system privileges. Now we're going to look at an end user. So we're actually going to go into the concerts user, and we're going to grant three very simple privileges. Select on the ACK table to Joe. We're also going to grant select on the show table to Joe. And we're going to grant select on the venue table to Joe. Now we're going to connect this Joe. Now, let's try to select star from concerts.act. I have to use the schema name concerts because the table act is in the concerts user. All I'm allowed to do is access the table, and there I have the data. Now let's try and access another table which I don't have access on, from concerts.category, and it will say it's not found. I can also select star from concerts.venue, and the same thing would apply to the show table. Now let's go and take a look at the object privileges granted from the concerts user to the user Joe. So we know we're logged in as Joe. So what we're going to do is we're going to look at in a view called user tab privs, user tab privileges. I'm simply going to say select star from user tab privs. What I have is the grantee, the user receiving the grant, the owner is concerts, and the table name. Now let's go and take a look at some roles. So first of all, I'm going to log into my database. And I'm going to log in as system in Oracle Enterprise Manager. I'm going to go to security, and I'm going to go and look at roles. So let's click here. Roles that are interesting. As you know, connect and resource are generally deprecated. We'll have a look at that in a moment. DBA is the database administrator role. Export and import full database allow you to use the export and import utilities to do full imports and exports on the database. Generally, export is sometimes used as a full export as a backup. That's database administration though. Another interesting role is the select catalog role. This allows you to look at all the metadata, dictionary and performance view Oracle views.
Let's go and take a look at connect. The connect role will have certain system privileges, namely alter session plus a number of system privilege create roles, create cluster, database link, general database objects, table view, etc. Let's have a look at the resource role, generally used for development. It has more or less the same sort of thing as connect, other than the fact that it has the option to create other database object types, such as procedures, operators, index types, etc. What I'd like to do now is to go through an example process. In grouping privileges using roles, I'm going to show you how to create a role, how to grant system privileges to that role, and then how to grant that role to a user, namely the developer user. We're also going to learn some tips and tricks using SQL Plus to find out how to process large numbers of records using output spool files and concatenated strings within select statements. We're going to go through a sequence of steps. Let's go through those steps first just to see what we're going to do. First thing we're going to do is going to create a role called developer, a new role. Then we're going to find all the system privileges that we've already granted to developer. We're going to put it into a spool file. Then we're going to take all the system privileges in that spool file and grant them to the role develop. Then we're going to remove all those system privileges from developer by using the revoke command. Then we're going to grant the role develop with all its system privileges contained within it to the developer user. And then we're going to show the developer user has no direct system privileges, but that it has the privileges that it had before, except that it now has them through the role rather than directly. So we're going to test it. Let's connect to the database as the system user. Now let's go and create a role called develop. Role created. Now we need to go and look at the system privileges granted to the user developer. So we're going to have to connect. Well, we don't have to connect to developer, but it's easy to do it this way. First thing I want to do is to set the headings off. I can do this by setting pages 0. Now what I want to do is to output the system privileges granted to the developer user to a file. So I'm going to say spool and drive C in a temporary directory. I'll call it sysprivs.log. And I'll paste in a command I typed in earlier. What this does is it says select from user privs the column privilege. And I'm concatenating in these pieces of text. So I'm actually going to have select, and it's going to come out and say grant privilege whatever it is to develop. So let's run this. Now let's say spool off to close the text file. Now we'll go and have a look at the text file. This is the text file we created with the spool command. What I'm going to do is I'm going to get rid of the extra lines. We can automatically not produce these extra lines from SQL Plus, but that's a little complex for now. So we'll just remove them manually. Now I'm going to save this file. I'm going to go back to SQL Plus. I'm going to log into system because I cannot grant those system privileges to the develop role unless I'm logged in the system. I certainly can't do it from the developer user unless I was to give the granting privilege to the developer user, which I don't want to at this stage. What I'm going to do is I'm going to run this script now. And this grants all the system privileges to the role. Now what I want to do is I want to revoke all the system privileges from the developer user. Now I could go into SQL Plus and I could type another fancy select statement and produce a set of commands that say revoke system privileges from developer. What I'm going to do is I'm just going to go to the text file which I used last time, and I'm just going to replace everything. Seems a little easier at this stage. And what I can do is I've replaced grant with revoke. I'm going to replace space to develop semicolon with space from developer. This is pretty simple. I'm just telling you what I'm doing so it makes sense. And now I've got a whole lot of revoke things from something. So I'm going to save this file. I'm going to go back to SQL+, logged in as system, and I'm going to run this script again, but with different commands in it. So what I did was I granted all the system privileges to the role. Now I'm going to revoke them all from the user. And there we have revoke succeeded. Now I'm going to go and grant the role itself, called develop, to the user called developer. I'm going to log in to developer, and I'm going to check the user system privileges in the developer. I can see that the developer definitely doesn't have any system privileges. Now let's see if I can create a table whilst logged in as developer. So create table test with a single column, nice and simple. And no, I can't. The reason why is because I have revoked too many privileges from the developer user. What I need to do is I need to connect system and go back into my DBA user, and I need to grant unlimited table space to developer. This is a privilege that cannot be accessed through a role. Now I will connect back into developer, and I will try to create a table again. And there we have it. So it's clear that the developer user still has access to system privileges, although these system privileges do not come from this particular view. They are not direct system privileges other than the unlimited tables-based system privilege. These privileges come from the role develop, and we can find these by looking at the role sys devs view. And there we have it. All the system privileges granted to develop, the role develop, which is in turn granted to the user developer. The set role command is used to enable and disable roles assigned to a user within that session based on a per session basis. As you can see from the syntax diagram, all will enable all except roles, none will disable all the roles, and you can set role a role name and enable a specific role and even identify it by a password. Let's look at the roles for the current session whilst logged in. I'll type select star from session roles. Now what we can do is we can disable that role. Set role, let's just say disable all roles, and then select star from session roles. Again, we have nothing. Now we can say set role the role name, and once again we enable the role. Note that we can actually identify and enable a role by a password. How this would function is that if developer enabled his develop role and identified it by a password, and someone else, such as another user, had access to the developer user, they would have to have a password to use the system privileges granted through the role to developer. This provides a measure of security for that particular role within that username.